All right, so good evening, everyone. You're welcome to today's class. And today we'll be talking about entity relationship diagrams, ERDs in short, which will help us to understand better more about object-oriented programming, OOP. So in order to delve into that, we need to understand what these ERDs mean and how does it help us to design and implement our code and all. So before I proceed, I want to ask, has anyone come across this concept before? Entity relationship diagram. Yeah,
Okay, good
this
evening.
new to you. Yeah, good evening.
Though I have come across it before, but I haven't make use of it as more as often.
Okay. That's fine. Who else?
Yes, I've also come across it before. It
All
uh, it,
right, so
it
you
shows
are, it's not, go ahead.
okay, it shows the relationship between each functions, such as maybe like let's use if as an example. Like now, if you are using if condition, it will show the entire layout of the database, both
Okay,
the
exactly.
user interface and the
All right, that's fine. Thank you. So today we're going to explore entity relationship diagrams. So you can just think of these ERDs as a blueprint for your data. That's a way to visualize how all the pieces of information in your system fit together, right? We will soon be building software for schools, for um, many industries and the so we need to know how to design. There are steps taken in order to implement or execute a solution and all, right? So before you code, it's expected that we design the structure that will guide us in what to do when we are implementing the code. So that's what we are going to talk about today. So we'll look at what an ERD is, why do we need it, why is it important in OOP, the core components of ERD, have the entities, attributes, relationships. Then for cardinality, we would know what how many is, what the meaning of how many, one to one, one to many, many to many. Then we know how to connect that to code and putting everything together. All right, can I be heard?
Yes, sir.
All right, thanks. So to lay the foundation now, right, before I proceed, um, have we all seen, when you want to build a house, right? When you want to build a house, you don't just go ahead and lay blocks and all. There's something you need to do, right, in order for you to start building. So, at the gift, what's that first thing people do when they want to start building their house? What do you do first? Assuming you want to build your own house. The gift, are you there? We will not be coding today. Oh, no code today. Next class we'll code. Yeah. The gift, can you hear me? Oh, seems you can't hear me. Okay.
I'm just answering now. Sorry. Sorry, you are calling my gift. Is question you asked.
Don't worry. Don't worry. It's fine. Precious, do you have an
Yes, sir.
idea? Yeah. So when you want to build a
Some people
house,
call
what
it
do you do? Okay, go ahead.
some people call it blueprints. That's the word that just in my head.
Blueprint. Is that what did? Okay, blueprint. All right. Abdul Salam. All right, Sammy, I'm coming to you. Abdul, what they do first, assuming you want to build a house, do you just tell the laborers, "I start building," you know? Abdul, are you there? Ayana, Sammy, go ahead.
Okay, before we start building the house, we need to call the architect to draw the floor plan, this cross section of the house, for we to preview what the house will look like on the paper first, so that for we to know how to go about it when the building started properly.
Exactly. When the building started properly. So that summarizes what ERD is all about, right? So as what Sammy have said, before you start building, you need to contact the architect who is going to design the architectural structure of the house, where the rooms, assuming it's a 3 bedroom, right? You'll be the one to tell the architect to design it in a way whereby there will be 2 rooms down. Then maybe there will be 3 toilets in the design. So once the architect has designed everything, before they start building, the architect will have to show the owner of the house, this is what I have. Is this fine before we start building? If it's okay, then they start building. Now, if I would ask, why is that necessary? Why is it necessary to um, design first? Why is it necessary to draw everything out? And what is the danger? What are the dangers? Or what is the danger of not doing it and you just go ahead to implement? You just go ahead to build. Like, what's the disadvantage? What's it going to do? All right, Sammy, go ahead.
Okay, one of the advantages of we drawing out plans before starting construction is, first of all, to save time and cost, because if we don't do that, we are just like beating around the bush. We might not be for we to have a laid down structure, so that when we follow that path, we first of all meet up with the required time, and also it will save us extra cost of doing what is not necessary. So it will help us to go straight to what we needed and we build it at the same time.
Exactly, exactly. So to summarize what he said, it's more like you want to build a 3 bedroom and they go ahead and build it and you were like you are finished building, maybe they're finished building the 2 rooms and you're like, oh, I didn't want this room to be like this. Should have looked this other way. The position of this room is not what I wanted. Scatter everything and do it again. Imagine that. You see the stress in having to waste time, resources and all, and you have to start all over again. But if you had designed everything on paper, done the whole architectural structure and all, and you show the owner will be like, okay, I don't like the position. Please, can you put this position here on the paper? And then the architect will go ahead and redesign the stuff. So by doing that, you haven't spent money building, right? You have actually done the corrections on paper. So once everything is done, once everything is clarified on the paper, then they start building and you notice that you won't end up wasting your resources and all. Are we good? The gift, is it clear? Okay. Oh. All
Yes,
right.
sir.
All right. Thank
Yes,
you.
sir.
Hmm. So what exactly is an ERD, right? So at its core, an ERD is simply a visual representation of relationship between different things, or these different things, we call it entities in programming. We call it entities in programming in any given system. So like I said, imagine you are building a system for a school. Now, this is not building a house now. Now we are going the lane of talking programmatically, right? You are asked to build a system for a school. What are those key things, right? What are those key things you need to keep track of, right? What are those key things you need to keep track of? So one of them is you need to keep track of the students, right, which is part of the school, and that's regarded as an entity. You need to keep track of the courses. You need to keep track of teachers, or perhaps you need to keep track of classrooms, right? So an ERD helps you map out these things and how they interact, right? It's like drawing a map or a blueprint for your data before you start building your database or writing your code, right? The goal is actually to clearly model real-world objects and their connection. That is the goal. You be given projects to do, all right? And the first thing you need to do is not to implement. You have to start by developing the skill of learning how to structurally represent what you're asked to do using ERDs, okay? So you would learn to, at the end of today's class, you will be able to know how to visually represent real life projects using ERDs, okay? Any question? Are we good? Hello?
For me personally, it is well understood, but I don't know of others.
All right, I need to get feedback. Are we good? Can I proceed?
Yes, I can proceed. You're good.
Okay, thank you. So why ERD before object-oriented programming? Like, why do we need to learn this before we start learning about OOP, right? ERD provides a conceptual foundation for OOP. It provides a conceptual foundation for OOP that maps almost differently or maps directly to OOP concepts, right? So the first thing here is each entity you identify in your ERD, like a student or a course, will often become a class in your OOP, right? You are asked to design a school. The first step is identifying those um look-alike entities, right? Which can be seen as a noun. As we go further, we would know what all these entities are, right? Look for those things that we can represent in our code, right? So for example, the student is an object, okay? So once we have identified that entity, that entity we have identified is known as a class in C sharp, is known as a class in the code. So every entity you identify is actually a class in OOP. Are we good? Hello? I would want to
Yes,
get
sir.
feedbacks. Yeah. All right.
Yes, I
Thank
was
you.
good.
Yeah. So after you have identified the entity, the next thing is the attributes that describe your entities. Yeah, the attribute that describe your entities, like a student. What are those attributes of a student? We have the first name, we have the last name, address, phone number, or aside the student, what else can be an entity? We can have a course or subject, right? The course. So what are the attributes of that entity course? It could be the title, which is introduction to chemistry. Then we have the units. How many units does that course offer? Which could be 4 units or 5 units. So all those are regarded as the attributes. Okay. And then finally, we have the relationship between entities, like a student enrolling in a course. That is a relationship. We have the entity called we have two entities. We have the student entity and we have the course entity. How do they relate together? They relate together by saying the student registers for a course or the student enrolls for a course. That is the relationship between the two entities. So once we are able to identify the entity and also get all the attributes for the entity. The final step is how do they relate to each other, okay? So by designing your data structure with an ERD first, you set yourself up for a much more logical and maintainable OP design later on. Are we good?
Sure, good.
Okay, so core components of an ERD. What are the components of an ERD? First, we have the entities. These are the main things we are interested in. The main things we're interested in. We have the attributes, like what do I mean by attributes? Like the characteristics or details that describe each of those things, that describes the student, that describes the course, that describes the classroom, which are all entities, right? So attributes are the characteristics of the entity. So what's the characteristics of student entity? It could be the first name, last name, address, gender, and so forth and so forth, right? And finally, we have the relationship, the association or links between these two entities. Okay. Any question? Okay, let's proceed. So each component has a specific symbol, right? Entities, we represent entity using rectangle. When we go into one of the tools that helps us to represent all these diagrams, so we'd understand better. So for entities, we use rectangles. Then for attributes, we use the oval, or connected in entity, or in some notations, where I'm going to show us a simpler way to represent entities, attributes, and the relationship between the two. All right. Entities. Let's start with entities now. So these are fundamental things or objects in your system about which you want to store information. So you can think of entities as a noun in your system description. So aside school management system, let's talk about banking system, right? So for the banking system software you are asked to design, what are those entities? Entities like structure. Customer is an entity, right? Who can mention other? For the banking system, who can mention any entities you would feel is actually an entity?
Employee.
Sorry?
Employee.
All right, employee is an entity. Okay, thank you. Who else?
Admin.
Admin is an entity. Okay, who else? Everybody must talk. Oh. Let me check my attendance. Okay, Teligwe, mention one entity when you are trying to talk
Oh,
about or
I'm the one that
using.
just said I'm admin.
Okay. Abdul. Abdul.
Stab.
Okay, you are next. You were not following. Okay. Oh. All right. At the gift, okay, you said something. Isaac, what are those entity? When you're talking about banking system, mention one example of an entity. Isaac, I can't hear you. Okay.
Hello, can you?
Yeah, I can hear you. I can hear you.
I said the workers.
Workers. Why is everybody talking about persons? Anyway, it's fine. I understand. Okay, Precious.
So I already said the employees, but
Okay.
another one is account balance. Is balance like that.
Okay. That is account. Yeah, account. Account is also an entity. Then what you do in the bank, right? They call it transaction. All those activities you do. To summarize, that is a transaction. That transaction is also an entity. Okay. Then we'll talk about school. For the school, we have the students, we have the courses, we have the teachers, we have the classroom, and all. Okay, so these represent a distinct real world object or concept, and their representation is very simple, just a rectangle with the name of the entity clearly written inside, usually in singular form. For instance, we have the student. So let's go to, I'll be making use of draw.io. Draw.io is draw.io. It's a tool that helps us to draw ERDs, right? It helps us to represent structures like that. And instead of going to your paper or your book and writing it out, you can actually use one of these tools. There are other tools aside draw.io. We have Lucid Chat. If you've heard of Lucid Chat, if you have access to it, you can actually use that for your ERDs. But I don't use Lucid Chat because it's limited. You have to pay for those advanced features and all. But for draw.io, it's unlimited. You can use it for basically everything, right? So we'll be using draw.io in our class today. So let's try and practicalize how do we represent entities in the draw.io. So I'm going to go over to the draw.io tool now. Okay. All right. Can you see my screen?
Not yet.
Okay.
Slide, you are seeing the slide.
How about now?
Yes, we can see it now.
Okay. Right, let me do something now. Not supposed to do this. So, okay. All right. So this is how we present entities, right? This is an entity where, let's assume we have a student entity, right? A student entity. How do we present a student entity? Okay, Samuel, go ahead.
Sir, please, can you take away the table? Let's start from where you created the table from, please.
Okay. Sorry. All right, I've
Thank
taken
you.
it away. All right. So if you go to your sidebar, right? So you are provided with symbols and tools you would need to represent your diagrams and all. So if you come over to entity relation, you would see this table, right? This table, you see this table, which is what we are looking for. There are others we can, for those who go to maybe a product managers, they make use of flowcharts where they have to draw the schematic structure of the whole software and all, right? So today we'll be using this. Okay, Precious, go ahead.
Yes, sir. So I'm trying to access the draw.io, but to just keep load and say please ensure JavaScript is enabled.
Draw.io, draw.
Yeah, it will load. It will load.
It will load. Yeah, thank you. It's going to load.
I also have that experience.
Just hold on. I think it's loading. Yeah. All right, thank you. So we have the table, and once we click, it comes here, right? It comes here, and this is what we got. And I had to delete this because we don't need it now. Okay, we don't need it now. We don't need this now. All right, we don't need this now. What we need is the header. So this is what we use to represent the entity. So for the entity, we want to represent student entity. So for here, we just type student. Okay. Then we are going to make use of three entities, right? So we have the student, we have the course, right? So what I'm going to do, since I want to duplicate this for course. So all I just need to do is I'll highlight on it, then Control D. Control D is to duplicate it. Then you drag it here. Sorry. Are we good?
Yes.
Dragging and all. But I need three. I need students. I need course. Course, and I need I think let's just make do with this too. Then we can have, for the banking system, we can have customers, right? So we can do something similar. Put it here. Let me put this one here. Okay. So we can have customers. We can have customer rather. That is an entity. We have customer. So all this you see here, when you see something like this, one thing that will come to your mind is that that is an entity, and this is how we represent entity in the tabular structure, right? This is the entity. Are we all following?
Yes, sir.
Yes, sir.
All right, thanks. Let's go over to the all right, so after entity example, we have the student, the course, the book, an order, a customer. All right, next is attributes, right? If entities are nouns, then I describe those nouns. So they are the pieces of information you want to store about an entity. So an example is for a student entity, what are those possible attributes? So the attribute would include the name, right? We have the name, the email, the student ID, the date of birth, and all, right? So a very important type of attribute is actually the key. There, I'm going to come to that. I'm going to talk about the key later on. So how do we represent attributes in the ERD structure? How do we present that? So we'll just go over there to the draw.io. So for this student entity, the name are written in the rows, in form of the rows, right? The rows are for the attributes. We have the name, we have the address, we have the book. Mention over 5, up to 5. Let's see. Name, address, what else?
Email.
Student ID, email.
All right,
Age.
email. Right. So notice this. This is not enough, right? If I want to still add more, all I just need to do is come here, highlight this, and Control D. It's going to duplicate more, right? So email, we have the date of birth. We have the, what else? Phone number and all. So all these are the attributes, okay? For the course, we can have, I purposely left this one blank because of a reason, right? I'll come to that. So for the course, what are those possible attributes?
Title.
Course
All right,
code.
title,
Course code.
all right, course code,
Description. Yes.
what?
She said
Come again.
description.
Okay,
Description.
description.
Yes.
All right.
Course
So,
unit, if it's the
okay.
university course.
All right. Course unit, which is unit. Okay. All right. Unit. So all these are the attributes, and this is how we represent the attributes and all. Now, let's talk about the primary key. All right, let's go back to the code. Where do I have this? All right, key attribute, the primary key. It says an instance of an entity. It's crucial for linking entities and all. So what's this primary key? What is it all about? What does it do? Right? If we go over here, primary keys are unique attribute. They are unique. It is not duplicated, right? So without primary key, right, one thing we try to do as backend developers, right, we'll be communicating with the database. We try to avoid scenarios whereby we have duplicated data in the database. It is not good. When you have a data that is duplicated in your database and there's nothing to uniquely identify that this is different from this, it's really going to cause issue for you as time goes on. So what do I mean by that? For a school management system, right, you are asked to design the system whereby students who registers for a course will get added to the database, right? So they register with maybe their name, address, email, date of birth, and phone number, right? So in your database, you can have the first student called Ede Gift, number 41 Street, right? That is the first student. Too. Then for the second student, you would have Precious Steve, then the address, so address, right? Now, if I ask, what will you use to identify um one of the entities? So what do I mean
Hello, sir.
by
It seems.
that? Let me
Okay.
try and write that here.
Oh, we can't hear
Let
you
me try
As
and
we
clearly.
write
can't
them
hear
out
you, it
so that
seems
we
the
all get the
network.
flow.
Hello, sir.
Where
Oh, we
do
can't hear you
I'm coming?
clearly.
Sorry,
Hello, sir.
can you hear me?
Your question, we can't seem to hear your questions because the
Hello, can you hear
network.
me now?
Yes, we can hear you clearly now.
But can you hear me?
Yes, we can hear you
Can you hear
now.
me?
Yes.
So we
Yeah,
can hear
I
you
want
now.
to hold on first. I just want to. All right, thank you. Okay, all right. So this is your database. You can see my sticky note, right? Oh
No.
God, my network.
Okay, we can see the note
Can
now.
you see my sticky note?
So
Yes, we can see that.
Can you see my sticky? Okay. Sorry about my network. So assuming this is your database that stores students' information, right? So this is how your database will look like in real scenarios where you would have your name, right? You have your name, then you have the email. You have the email. Right, let me do this first. Right, you have the name, you have the email, we have the address, and we have the phone number. So all these are the properties which is written in columns, right? Then for the rows, we'll have the different values. So assuming we have 5 students, or let's just use, okay, let's use 3 students. We have 3 students currently. So the first student is Precious Steve, right? First student, Precious Steve. Her email is precious@gmail.com. Then you can have, let me put this one here. Can have address as, hope you can hear me. Can you hear me?
Yes, we can
Yes,
hear
sir,
you
we can hear
perfectly.
yes,
you.
sir, we can hear you.
All right. Precious as address is number 4 Street, right? Then phone number is 070 da 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 da. So that's the first student. For the second student, we have this the gift, then email ede@gmail.com. Then address is address number 5 street, then phone number 081. Then finally, I'll just duplicate this first. Okay. Duplicate that, then duplicate this. So I duplicate that. Yeah. Come in. All right. Hold on, guy. I'm in class and that's all right. Can you hear me? Sorry about the noise. So we have the address, number 6 streets. That's the address. Then the email as Abdul. Then the name Abdul Rai. All right. So we have the hello, can you hear me?
Yes, sir, we can hear you.
Yes, sir.
Yeah, my system tripped off. Sorry.
Oh,
Let me connect again. Sorry about that. Right. Okay. Right. Can you see my screen now?
sir.
Can you see my screen?
Yes.
All right. So we have these 3 students currently in the database. And I would ask, which attributes do you think will be unique all throughout the database, right? When I talk about unique means something that is not likely to be repeated, right? If I ask now, can we make name a unique attribute in the database? Meaning, if we make name a unique name,
No.
it means it's not going to be possible to have name duplicated in the database. Do we all get the question?
Yes, sir.
All right. Who else? We all understand the question, right?
No, sir, we don't get you. You are breaking at some point.
But you can hear me,
I can hear you now. Yeah, but the
right?
question I did
So
not.
the question is, the goal is to make one of the attributes unique. So by making it unique means something that doesn't repeat, right? Something that doesn't repeat, an entity or a value that doesn't repeat in the database. That is what we call unique. Now we want to make an attribute a unique attribute in the database, right? So that's the goal of what we want to do. So the question is it right to make name a unique attribute for our database?
No, sir.
No.
No.
All right. Um, 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 Deligwe, is it right to make name unique for our database, a unique attribute for our database? All right, you're not hearing?
No.
No. Okay. Marian, is it right to make name a unique attribute for our database? Marian Uba? Or you're just joining? Okay, let's proceed. So for those that said no, like Precious, you said no. Why? Why can't we make name a unique attribute?
In the real world setting, two people can actually bear the same name and the same surname, so we can't actually make name unique.
Exactly. So it is possible that in your school, it's possible, like I remember in my primary school, someone, as the guy is from my community. So he actually had my first name, my middle name, and my surname. Yeah. So that's because of that, and the possibility of having names repeatedly is not going to be wise. Having name to be unique in for our database, right? How about address? Is it okay making address unique for our database?
No,
No, no, sir,
No.
not possible.
Okay. How about phone?
no,
Phone number. Eh?
no.
Yes, sir, phone number is possible.
Phone
It's
number
not.
is possible, don't you
It's
think?
possible. As,
Phone
yeah,
number
it's
is
possible. If it's possible,
It's possible, right? But
Should I
but
should I should I should I
to use email.
plead my case? Why it's not possible?
Okay. All right, now go ahead, shoot.
Okay, there is every tendency. Let me use my case scenario of a friend of mine that has his brother in our school, and they do take registration as well. So once
but it may
innocent
not be
innocent
Wait,
possible
wait, wait.
based on some
Let him
reasons.
finish first. Let him finish first.
once innocent registered his name, and or he will put his own phone number,
Mm-hmm.
because his brother does not have any phone at that moment, he also put innocent's phone number on it as registration. So definitely innocent and his brother are sharing the same phone number, so using that as a form of uniqueness in a data collection, it will be, there can be duplication at times due to that kind of a uniqueness.
Okay. Exactly. Who else want to um comment? Precious, you wanted to say something? Okay, who else want to contribute? Why phone can't be a unique attribute? All right, let's proceed. So one thing about uniqueness is that, especially when trying to store data in your database, when you are trying to name an attribute or identify an attribute as unique, you should conclude in your mind that that attribute will never ever change. Like it's never going to change. It's going to be till eternity. That's what it means. Till the life of that data is never going to change. That's what it means. So the reason why I said that is for phone number now, right? Phone number, the reason we can't actually make phone number a unique attribute is because, fine, is because today now, if I decide to register my course, I choose to use this phone number, right? And maybe after 1 year, I misplaced this phone number. It means I have to change it and use another phone number, right? Are we all following?
Absolutely.
Great. So that changing, that reason to change is more reason why we can't use phone for a unique attribute, okay? So that is cancelled out. How about email? How about
Email,
email?
with the same analogy you just placed right now, email address also can't be used because at some point, some people cannot retrieve their email. They need to create another email address. So there might be a tendency of we changing email address.
Okay. Who else want to contribute?
We can use email, but the difference between phone number. Okay, I think we can use email because email is usually unique. I mean, if I try to create an account now with, even though I can change my email, it's it's always unique because I cannot like create another account for me with another person's email or an account that already has another person's email registered already.
Okay.
So
All right. Thank you. So email is actually a unique attribute. Yeah, it's actually a unique attribute because I've been to you have actually everyone have experienced this. You go to a site, you try to register, or maybe you've registered before, then after 5 years' time, you still want to use the email you used 5 years' time to register, and it tells you this email has already been used. Have you seen something like that?
Yes, sir.
Exactly.
Yes, sir.
So that's
Even when trying to create an email account, if the email is already exists, you won't be able to do
exactly,
that
it's not
same.
going to allow you to use that same stuff because it has already been used, it has already been saved in the database. So assuming, for example, Facebook, you go to Facebook, you register using precious@gmail.com, and peradventure you misplaced the email, like you can't access the email, right? You are left with one option to create entirely a new Facebook account for a new email, meaning this old email for the old Facebook account is gone. Do we get?
Yes, sir.
Do we get the
Yes,
picture?
sir. Yes,
Right.
sir.
So email, in a real sense, is actually unique because two people cannot have the same email. It could be maybe I want to use precious@gmail.com and I type in precious and it says this email has already been used. Sometimes what I do is, since I want to still use precious, I just do precious 111 or maybe precious 222. Do you get who has done that before? Because you want to use your name, you just decide to add number to it so that it will work, right?
Yes.
Exactly. So me, there are times I will try the first one. If my name is Gideon, I will try Gideon@gmail.com. It has been used. I will try Gideon one. Gideon one has already been used. I'm like, how come? I'll come try Gideon 11. Gideon 11 has already been used. I say, okay, now let me try this one. Gideon 477441. Let me see who will use that one. Then you now realize that no born person to use that one. So email actually is a unique attribute. Then aside email, there's what we call primary key. There's what we call primary key, right? PK in short. Primary key is a unique attribute, right? So for every student that is saved in the database, for every student that you save in the database, there is a primary key that has been assigned to that newly created student, right? Which could be maybe Precious Steve was the first person to sign in, right? And since she's the first, she takes ID1 as her ID and all, right? So if the next student registers on the platform, it's not going to be 1 this time around. It's going to be what? 2. And that is how it goes on. For the third student that would register, it's going to be what? 3. So you realize that these keys will not be repeated. So if there is a new student that registers on the platform, the new student will take ID what? 4. Are we all following?
Yes, sir.
Yes.
Great. So that is that for it. So we'll be using primary keys because primary keys is a unique attribute in the database that doesn't repeat, it doesn't change. And also if I want to try to get student that lives in number 5 street, all I just need is to what? Once I get this ID, I've already gotten access to all the information about the student. Once I just have access to this ID, I have information about Abdul, his email, his address, his phone. If I have access to the ID alone, just this ID alone, I have access to everything about Precious. Do we get it?
Yes.
All right, great. So that is why for every entity you create, there should be an attribute called primary key for it. And how do we write that? It's always written at the top. So ID, and here we just denote it as PK, which is a primary key. So when the student is created, there will be an ID assigned for the newly created student. Same thing here. ID, PK, and all. So we have the student and we have the course. Let me just remove this one for now so that it will not overcomplicate so many things. All right. Any question before we proceed? All right.
Yes, I have a question, sir.
Okay, go ahead.
Okay, I saw when you're writing the primary key, I discovered that you are putting it on a cap lock like PKID, why the rest are small letter. Is it just for your own description or is that
Okay.
the
Yeah. For those that for JavaScript, for those that use TypeScript, JavaScript, right? How they name their properties, or these are properties, how they name it is in small case. But for C sharp, every property you try to declare is always in capital, right? Okay, so let's just, yeah, it's always in capital, right? Are we all following?
Yes, sir.
Different programming language have their structure, and or just for simplicity and to understand the code better, right? So then for this, we don't use snake case in C sharp, right? When trying to declare uh, properties, we just use Pascal first code. Yeah, that's how we do it. Description. Okay. Units. All right. Are we good?
Yes, sir.
Are we good? All right. Thanks. So let's go back to the slide. Who is making notes in this class? Abdul, I'll flog you. All right. So that is it for attributes. Let's go on to the next slide, which is relationships, like our relationships. Okay. So relationship, finally we have relationship. So this describe how two or more entities interact or are connected and all. So they are the verbs that links your nouns together. For instance, a student might enroll in a course, or an author writes a book. So the author is an entity. Book is the entity. What connects them together is actually the relationship. So an author writes a book, a customer places an order. So when we talk about those e-commerce applications like Jumia, Alibaba, and or where you want to order to buy a shoe, right? You are actually the customer. You are placing the order. So that is a relationship between you as an entity and the order, which is another entity. The relationship is that you are actually placing an order. Are we all following?
Yes, sir. Following, sir.
All right, great. Okay. Cardinality. The cardinality, how many. So once you have identified your entities like students, then the attributes and relationship, the next critical step is to define their cardinality. What do I mean by cardinality? So cardinality answers the question, how many instances of one entity can be associated with the other entity? Like how many instances of one entity can be associated with the other entities, right? When they are related together or when they have a relationship together. So that will tell us the how many aspects, right? It's going to be confusing now. So, but when we do more examples, it will be clearer, right? So we have three main types of cardinality. We have the one-to-one, we have the one-to-many, and we have the many-to-many. One-to-one, one-to-many, or many-to-one, which is the same. So one-to-one, one-to-many, and many-to-many. What does this really mean? Okay. So one-to-one, let's break down this cardinality one-to-one. So this means one instance of entity A is associated with at most one instance of entity B, right? Or one instance of entity B is associated with at most one instance of entity A. Who just stepped out? Is it me? Did I just step out?
No,
Can
you
you
are
hear
here.
me?
Yes, we can hear you clearly.
I heard somebody stepping out. I thought I was the one that stepped out. Okay. All right. So one-to-one means one instance of entity A is associated with at most one instance of entity B. Or if you are looking at it at the B side, one instance of entity B is associated with one instance of entity A. So let's take an example. A person, right, has a passport. Is it possible for you to have more than one passport? In real life scenario, like your Nigerian passport, is it possible to have more than one passport?
Okay, you just said Nigerian passports. No, it's not possible for you to have more than one Nigerian passport.
Exactly. So that is why this cardinality is very important, right? We are programmers, we are asked to solve a problem. So before we go ahead to implement that in code, first we have to represent that using the ERD diagrams and all, where this cardinality is very important. This cardinality brings in real life scenarios, right? So a person has a passport, meaning this is actually a one-to-one, meaning a person, which is one, can only have what? One passport. One person has one passport. Then if you are looking at it at the passport side, and one passport belongs to one person, can it belong to two people? Is it possible?
No.
Great, it's not possible, right? So how do we represent this in our draw.io, right? So I have two entities called person and passport. So I want to create a relationship between the two, and we are using cardinality to create that relationship. So how are we going to make use of this? How are we going to draw it in a way that when somebody looks at our diagrams and sees something they look alike, he's going to say, oh, this is actually a one-to-one based on the diagram he or she have seen. So let's go to the draw.io. All right, I'll come to this later. Or let me do this. I can duplicate this. Okay. All right. So I have, assuming this is my, this is a person entity. And this is passport entity. We have the person entity and the passport entity. A person, don't mind this attribute, so I'm just trying to explain the entity, okay? Are we good?
Yes, sir. We are good, sir.
All right. So a person can have one passport. So what are those symbols we would use to represent that? So if you come here, we look for the gender lines, straight line, a straight line. Okay, this is a straight line. try not to use this one NM so that we don't get confused. I'll use a different one. Let's see. Okay, I'll create my own. So this is a fresh line. This is a fresh line. This is actually a fresh line. Now I want to represent one-to-one. I want to represent one-to-one relationship, right? So there is a symbol. There is how we are going to design this that will represent one-to-one, which we can use throughout our designs, right? Mind you, there are other ways to designing ERDs, right? There are other ways to it. So for some other ways, they use different symbols, which is similar to them but for our class, we'll just stick with this one to avoid confusion. But note that you might read other resources and you find out that the way the other guy implemented his own ERD is different from this. They're actually the same thing, but it's just like a language. The language is unique to you, right? How you choose to interpret it matters. Do we get it? Are we good?
Yes, sir.
All right. Okay. So one-to-one, how do we represent that? This is it. So we have this line. What I'm going to do is I'll come here to style. This is the beginning line. I'll choose the one that we use to represent one-to-one, which is this. Then I'll do same here, which is this. Right. So this is one-to-one. This is how we present one-to-one. If you check one-to-one, this is a symbol for one-to-one. Okay. Let me just duplicate this. I'll use it for other ones. Are we all seeing this? This is a one-to-one cardinality representation. Are we good?
Yes, sir.
Great. So how do we tie them together? A person has one passport. So it's just simply doing this and we're good to go. So a person, so by doing this, we have created a relationship. Okay, let me drag it here. All right, this is a relationship now. So by doing this now, it means this is actually when someone sees your representation or your diagram, the person will be like, okay, this symbol represents one-to-one. So it means a person can only have one passport, and a passport can belong to one person. Do we all get it? Are we following?
Sir, please come again.
Hello?
Sir, please explain it again.
Edegit, is that you?
Yes, it's me.
Okay, where do you want me to explain?
The last thing that you just said, like concerning the one-to-one, like the person and the passports.
Whenever you see a symbol like this, where we have this straight line here and this straight line here, right? That is a one-to-one, right? One-to-one representation, right? That's a one-to-one.
Yeah.
So in this slide, I said an example of a one-to-one cardinality is a person can have one passport. The person can have more than one passport, right? So since
Yes.
a person or since the gift can have one passport, it means we would use this to represent that relationship, right? We'll just use this to represent the relationship of the one-to-one. We'll use this to represent that. So if someone comes to your diagram and see this design and you ask the person, So you have seen this my diagram. What cardinality is this? The person will be able to tell what cardinality is this based on this symbol we have seen here. This straight line here, this straight line here. Sorry, the noise. Hold on. Right. Can you hear me?
Yes, sir.
Great. So 1 to 1. That's all it means. Do you get it now? Hello?
Hi.
Is it clear?
Yes, sir. Yes,
Is it clearer
sir.
now?
Yes.
All right, great. Great. Let's proceed. So let's go over to the next cardinality, which is the all these ones I did here, where they say notations provide crowds put a straight line with two single lines at each end. A straight line with two single lines at each end, or just one at each end. That represents the 1-to-1. So that explains that. That's the notation for it, right? So aside this, who can give me a scenario, real life scenario of 1-to-1? It could be a hospital software or anything. Just tell me a 1-to-1 relationship in real life. You can just pick two entities and tell me the relationship between the two of them. Who wants to go? Hello?
Hi, sir.
All right, go ahead.
I think students and student ID
Student and
and
student
student
ID.
ID.
Okay, yeah. So a student can only have one ID throughout his or her stay in the school, right?
Yes, sir.
Then that student ID can belong to one person. So you can see that as your matric number, right? Your matric number is also that, right? Yeah, there was a time in my school, someone was okay, there's this person that's always there's this guy that performs well in class. So there's this other guy that was claiming that the matric, in school system now we just go to the board to check the result. So this guy actually went to check the result and noticed the guy that performed well and decided to. So someone asked him, "What's your matric number?" He's going to use someone else's matric number to say it's his own, that kind of thing, which is not possible now, right? So meaning two people cannot have the same matric number, right? Are we good?
Yes, sir.
Great. So that is it. Who else want to try? 1-to-1. Everybody must speak because this is very, very important. This ERD concept is very important. So who else want to go ahead? I'll call names. So if you don't speak, it means it's not clear. I mean, there are so many 1-to-1 relationships in this whole wide world. So, okay, let me call names. I'll start subtracting marks from your tax. If you don't answer. Emmanuel, you have been quiet. Yes. 1-to-1 relationship.
I've been quiet because I just joined the meeting not quite long. So for
Hey,
one-to-one relationship,
okay.
can you hear me?
Yeah, I can hear you. I can hear you.
Okay. For one-to-one relationship, we here, students and CodeCamp certificates.
Eh?
When we finish the program, the certificates that we're going to get everybody to their own certificates. So that seems like a one-to-one relationship.
Okay. Everyone to their certificate. Everyone to their certificate. I don't agree, because in the certificate is possible that me and you bear the same Emmanuel and we can have the same certificates, and inside this, the content will tell if it's actually unique.
How about NYC certificate?
NYSC certificate. The NYSC, the ID you are giving is unique. Yeah, exactly. So the NYSC certificate, because of the content, in the content, there is the ID, NYSC ID, that is given to all corpers, right? Which is unique for them. So NYSC certificate, a student can only have one NYSC certificate, except Nigeria have changed where they can have more than one. All right, nice. Abdul, one-to-one relationship.
I think use a bank user and account number.
Exactly. Bank user, a customer, then
Yes.
account number. So a customer, wait to wait to wait to wait to wait to wait to. A customer, I disagree. Oh. You know why I disagree?
Why, sir?
That is a bank system, right? In my
Yes.
bank, wait, is it possible to have more than one account number in one bank, like UBA? Like, maybe I created an account,
Yeah, I have
saving account,
I
It's
have
possible.
two
then current
accounts with
account.
Fidelity
Yes,
too.
it's
Eh?
possible. It's possible.
I have
So
two
that's
accounts with
not actually
Fidelity.
one-to-one, because if it's one-to-one, it means a customer is only allowed to create one account for that bank. Do you get?
Okay. Okay. Patient and NHI's ID.
Okay. Patient and yeah, ID. Any ID that is used, all those IDs, they are unique. Why is everybody using ID now? Leave ID. Use real life listing now.
User and profile.
Okay. The user can have just one profile, yeah? User and profile, yeah? One-to-one. And the profile can belong to just one user, okay? All right. But we all get the flow now, right? Do you all understand?
Yes.
All right, great. So let's move over to the next, which is one-to-many. One-to-many. So this is a very, very, very common type of relationship. So in here, one instance of entity A can be associated with one or many instances of entity B. I'll take it again. In here, one instance of entity A can be associated with one or many instances of entity B. Or if you are looking at it in the B side, an instance of entity B is associated with at most one instance of entity A. At most one instance of entity A. Don't worry, it's somehow confusing, right? So let's see the example. A department has employees. Does that make sense? Does that represent one-to-many?
Yes, sir.
Right? So one department can have many employees, but each employee belongs to only one department. Each employee belongs to only one department, right? So one department has many employees, but the employees can belong to one department at a time, except some organizations, I don't know, an employee can belong to two departments. Is that possible? Is that possible?
Yeah.
Hmm?
Yes.
Okay, it's possible, right? Great. Since that is possible, don't worry. We'll come to that later. We'll come to that one. All right. So aside this example, what other kind of example, aside the one-to-many, who can tell me some possible one-to-many relationship? So okay, before I proceed, let me just go to the draw.io to represent that first, right? So for one-to-many, right? Use this. Let me take this here. So for one-to-many, right? This that represent one-to-many. For this side, we just use one, right? Then for this other side, we use this to represent many. This will represent many. So this is a one-to-many flow. One to many. Do we all understand the symbol? These are represent one-to-many.
Yes, sir.
Great. So how does that connect to two entities? We can't use this here. Who can tell me why? If I
You
use
said
this
you
here,
said we
what
can't
does that mean?
Because this one is that attribute.
Sorry?
Because it's an attribute.
Because it's attributes.
Because one person can only have one.
Exactly. Because if I put this here now, it then means that a person can have many passports. Do you get it? Do you understand?
Yes, sir.
Great. So that's why I can't use
Hello,
that.
sir.
Yeah, I can hear you.
But with what you said just now, without looking at just Nigerian passport alone, a person can say have two or more passports if it is like okay, someone that has Nigerian
No,
passport.
no, okay. Don't worry. Let me put Nigerian passport because
Uh,
before someone says my passport, I went to take passport. I had 10 passports. But let me just put Nigerian passport before it brings confusion. Now it's clearer now, right?
sure, sure.
Great. Yeah. All right. So from the example, we have employee and department, right? Employee and department. So still use this flow, duplicate it, and take it up. Let's stay here. All right. So we can have employee, department, employee and department, employee and department. So how do we represent the one-to-many? So we just need to use this symbol to represent the relationship between the two. Yep. One to many. Yeah. So we have one to many. So if someone sees your diagram, they'll be like, okay, this employee belongs to many, one or many department, right? One or many department. But there are some symbols whereby you need to tell that it's actually, because if you do it this way, it means an employee can belong to many departments. But if you want to really be explicit, right, you can decide to use this or that symbol attached to it. You can decide to use this. Wait, oh, what am I doing? Department should be here. Okay. Yeah, department should be here. Department should be here, not the other way around. Okay. All right. So a department can have many employees. Do we get it? Can you hear me?
Yes. Yes.
All right. The department can have many employees, and an employee can only belong to one department. The way you structure, that's why this design is very important, because your organization is different from my organization, right? In your organization, it is possible for an employee to belong to 3 departments. Do we all get it? Hello? Great. So if I, as a client, comes to meet you, a software developer, and I tell you to build a software for me, I will give you details of how I want the software to look like. And one of those information I'll provide to you is that, note that in my company, an employee doesn't belong to more than one department though. So design it in a way that one employee for one department. Do we all get it?
Okay,
Is
sir.
someone confused? Hello?
So we are good.
Are you sure? Hello? Are you sure? Are you sure? Are you sure?
Yes.
Yes, sir. We
Oh,
are good, sir.
great, great. That's it. So the way you design your software will be different from how I'm going to design mine, because the client has told me that for their company, they have this design flow where an employee belongs to one department. Meanwhile, for the next client in their own department or in their own company, it's the other case, meaning an employee can belong to more than one department, right? That is unique for their own organization. So you are going to design the software to suit their organization. Do you get it?
Yes.
Great. Yeah, thank you. So aside this department employee, what are other possible one-to-many relationship you can think of?
One
Uh,
student
a
doing
customer,
many courses.
Okay, go ahead, Emmanuel.
okay, this is Samuel.
Yeah.
A
Okay.
customer can have many accounts in the bank. When I mean account, that means account type domiciliary or local accounts.
Okay. They can
Yeah,
have
and
one or
yes,
many.
yes, one or many accounts. Why one account is one or many
Cannot be
accounts,
shared. Yeah.
yes, can be shared to just only one
Yeah. One
customer.
customer. Okay. That's fine. That's great. Okay. Emmanuel, go ahead.
Yeah, students offering many courses, a number of courses. One student to many
Exactly.
courses.
Exactly. A student offering many courses. Many courses. Hmm.
And BVN to accounts.
Wait,
BVN.
oh, you say what?
BVN and
Okay.
customer accounts.
Yeah. BVN to many accounts, exactly. About the student having to it's possible, okay, student offering many courses.
But one course can be offered by many students.
Okay, exactly. That's where I want to drive at now. That's where I was driving at, which, like, okay, there are times when we try to design this or here, this stuff, and it has to work for both ways, right? One to many, many to one. So for that student offering many courses, that is one to many, fine. Now, you look at it at the course side. If the course cannot be offered by one student, then it's not going to work well. Do you get it? You are saying one-to-many, right? For the student side, a student can offer many courses. So let's say, assuming one of those courses, Maths 101, right? We have course Maths 101. Now, at the course side, is it possible for Maths 101? Is it possible for many students to offer Maths 101?
Yes.
Hmm?
Yes, possible for many students to offer
Yes.
Math 101.
So it's possible for many students to offer Maths 101, right?
Yes, sir.
Ehen.
So
Don't worry,
that would
that is even
that
taking
would be
us
many to many.
exactly. That's even taking us to the next concept, which is many to many. So when you notice that the first entity and the second entity is one to many, and for the second entity to the first, if it is many to one, then it then means that that's many to many, right? But if it is many, if it is one to many at the other side, right, it's going to be one to many. Don't worry. Let me use another live example first. Sorry. Okay. Let's just say customer and customer and orders, right? Customer and orders. So what's the relationship for that? Customer and orders. Let's say in an e-commerce like Jumia, you are ordering for items. Customer and orders. What's the relationship?
One to many.
Right?
Yes.
One to many. Then in the order aspect, in the order side, what is it
That
going to
is
be?
that is okay, let me use it in this English word. Like a
Mm,
customer can take many orders, but many a customer can take many orders, while many orders can only be taken by one customer. Abi, am I
many
wrong with that
orders
English?
can be taken by one customer because the order that is created is actually unique for that particular customer, right?
Yes,
Do
sir.
you get it? Then for courses, for things like courses is Math 101 now. That's the unique code now, Math 101, which is unique, right? Course Math 101, I can take Math 101 in my first semester. Another student can still take that same course. Do we get it? Do we get the flow?
Yes.
So that's the whole flow. Don't worry, this thing, this ERD, it comes with practice, right? You just need to. I would give your next task step will be on it. You would have to pick either school management system or um hospital or anything. You'll be asked to design an ERD, represent what you are just design a visual presentation of the school management system. So by doing that, it's going to become clearer. Okay, it comes with practice. Are we good?
Yes, sir.
All right, let's go to the final one, which is many to many. So we have many to many. So
So we can
this
hear
is
you.
when an instance of
Oh.
entity A can be associated with one or many. Is it only her? Can you guys hear me? Can you hear me?
I can hear you clearly. I can hear you
Hello.
clearly.
Hi.
I can hear you clearly.
Okay, okay. Then it's your network. Oh. Then it's your network. Oh. Don't accuse me. All right. So many to many. This is when an instance of entity A can be associated with one or many instances of entity B, and an instance of entity B can be associated with one or many instances of entity A. At least you have seen this based on the example we did now. Like you see now, the example is a student can enroll in many courses like Math 101 But this same Maths 101 can have many students. Do we get it?
Exactly.
Yes.
Great. So that's just it. Any question? All right. So the many to many is this actually. Let me go to my. All right. Student and course. Yeah, this is already set up here already. So student and course. Right. Students and course. Many to many. So I will still use this. Then I'll tweak it. Right. So students and course, we just use many, which is this representation, many to many. So this is many to many, right? We have many to many. Then this many to many, right? It's also important to know that, especially OOP, that direct many to many relationships are often resolved by introducing another entity that would connect the two tables, right? Whenever we have whenever we have many to many relationship, it's very difficult to represent that in the database, right? It's not going to be clear to you now, but just know, because when we go into that practical aspect, right? You would remember that I said this, and there's a way we handle that, especially when we have relationships that are many to many. That is where we introduce, there's what we call a bridge. They call it a bridge table. A bridge table is useful in scenarios of many to many, right? I'm not going to go in depth into it, right? But just note this in case when we go there, that for many to many relationship, it's difficult to represent that in database. So there's always a bridge, an entity that would help us to map the two of them, the two entities, right? Scope and or when we go further, it's going to make sense. Okay. Are we good?
Yes, sir.
Yes, sir, we are good.
All right. Now putting all together, putting all together, putting all together, putting all together. All right. How do we put everything together? So let's use a life scenario, right? Let's use a life scenario. Let me go to the ERD. Let me delete everything. So going to delete everything. Let's pick a project. Let's pick, and we can use tax
Banking
management.
system.
So I
Okay,
use school
banking system.
management, school portal.
School portal.
Yes.
Okay.
Our
And
product management.
eh?
School portal. I
Okay,
use
God.
inventor.
The one that the gift
Inven-
is just vocal tonight.
We're just going to pick 3 or 4 entities and connect them together, or we're going to do the other one. Because it's going to take time. So we just pick 4. So let's use university, right? University
School portal.
system software, right? Okay, great. So we are going to use university flow. So we have the student. Let me remove this now. We have the student, right? And we have the course, or we have the student, then we have the course, right? Okay, let's do this. Student, sorry. I'm trying to stuff this. Take this here. All right. Okay, student. All right. So we have students and we have the course. So student can can register for many courses, right?
Yes.
Yes.
Okay. Student can register for many courses. All right. The student can register for many courses. Now, we are trying to connect everything together. A student can belong to a department, like let's say petroleum department, right?
Yes.
Yes, sir.
Great. And that department can also be under a faculty, right?
Yes.
Great. So that's telling us that we're having two more properties we call the faculty and the department entity, right? So we are going to create a faculty entity. All right. So this is a faculty entity, which will have what? Primary ID. What are the attributes of the faculty? Eh?
Faculty always has
The name,
department. Yeah.
the name. Okay. What else?
Department.
Department.
Okay, great. Now, that will bring us to what we have primary key and we have foreign key, right? That will bring us to the concept of primary key and foreign keys. So now that we have faculty entity, and this faculty entity has an attribute that is an entity. That department is an entity. So how do we bring that information to this faculty? How do we bring that information? So this is how we're going to do it. Let me just write out the um the two of them, right? Uh, sorry. Delete, delete. So we have the name. Let me create another one. Sorry. Okay. So this department entity, we have the name and the ID. Now, faculty has department, and since this department, attribute department or property department is an entity, we need to tie this department ID to this faculty, right? And how do we do that? We just simply introduce the property and call it department ID. And this department ID, right, is the same thing with this one. And because we are targeting the key, the department ID key, we always assign here a foreign key. Everybody will be confused. Everybody is confused, right?
Yes.
Not really.
Eh? It's not confused to
Yes.
you because it's you have done it before. Don't worry.
I have not done ERD. I have not done the constructions before.
Okay. All right. Name, right? The reason why name is because there's no entity called name, right? That's why you can easily store name as a property for the faculty. But this department is an entity here, right? It's not going to make sense if I should create a property here called department. Here again, it's like creating two things, like having details twice, year and year. Do you get?
Yes, sir.
Great. So since this department is an entity here, I need to get the information. Like I need to get, it's just like this example we did here. Can you see my sticky note?
Yes.
Great. It's just like this one now. I have student 1, student 2, student 3, right? And assuming I want to, this is the student ID. I want to get this student. Let's say, assuming I have another entity called, course. Yeah. I have another entity called course, COURSE. And this entity course would have the name of the course. We also have the unit. We also have the student taking this course, right? It needs to get and track the student that is taking this course, right? It needs to track, okay, let's just make use of these three. The name, the unit, and also the student that is taking this course. Now, the name is not an entity. That is why it's okay to have the name as a property. Same thing with the unit. But this student now is actually an entity because of this student entity that we had here. Do you get?
Yes.
Great. So because since this student is an entity and I don't want to have details of this twice, having here and having here, all I just need to do is get the details of this primary key, like calling student ID, right? Student ID. So by saying student, having student ID, right? It means I will still be referencing this particular student by the ID. Do you get it? Don't worry, it's confusing now, right? But when we go into the practical part, it's going to make sense, okay? Yeah, I understand. It was confusing to me when I started, yeah, when I began this whole stuff. So I understand. But just be rest assured, when we go into the practical part where we see everything clearly in the database, it will make sense. Okay?
All right, sir.
Great.
Okay, sir.
Cool. So department is an entity. So I need to reference this department in my faculty entity. And by doing that, I have to call in the department ID here. And because I am referencing an entity that already has an ID in my faculty table, it's no longer going to be PK, right? Primary key. Because, okay, we know that it's actually a primary key in the department table. And because I have referenced it in the faculty table, whenever you reference an entity, we always target that ID, a foreign key. That's how we do it. We call it a foreign key. Whenever you reference an entity outside of your table, they call that a foreign key, right? Because the key is not for you. You're actually referencing another entity's key. It's just like saying, let's say this faculty now, I want to reference student, right? I can just go ahead and say S2A, the student ID. And because this ID, this student ID, this student is an entity, I will tag this as what? I'm going to tag this as a foreign key because this student ID is not for me. It's actually someone else ID. Do you get it?
Yes, sir.
Don't worry, don't worry. To make sense, yeah? To make sense. Don't worry, I understand. Hmm? Yeah, the gift and co. Don't worry, it's going to make sense when we go into the code. Hmm?
Yes, sir. I know you call me.
All right, all right, all right. That's fine. Thanks. So that's how we represent that. Now, let me delete this. Delete this. So we have name and department. We can also have dean. Dean of a faculty now, right? Shay?
Yes,
Yes.
and HOD.
HOD. Faculty has
Oh,
HOD. I
sorry,
thought it's
sorry.
department.
Department. Sorry, department.
Eh. All right. So for the department, we can have you can have sorry. Okay. Department, we can have HOD, like you said, right? What else?
Yes.
All right, we can have, let's just make use of these two. We have name, we have
Course
HOD.
advisor.
Sorry?
Course
Sorry?
advice.
Okay. That's pertaining to your school. Oh, maybe if your school, that's why I said your school, the operations or the activities in your school is just for your school, oh, right? So you can actually ask the software developer to design a software peculiar to your school alone. So if in my school I want to use your software, it's not going to work because how I operate my university is different from how you operate yours. Do you get it?
Yes.
Great. So
Okay, sir.
your
Sorry, sir.
school,
Is that where we usually so call the business process of each and every application?
exactly, yeah, the business process, the logic, and how it's going to be. In fact, it's the client and all that would tell you what they want. Yeah, what they want in the software. You get it?
Understood.
Yeah. So that's how it is. So in your university, you can have course advisor. You just want to keep track of that, right? Course advisor. In my school, I don't have this. So if I should want to use your software, it means I have to go and employ somebody as course advisor for my department so that I'll be able to use your this thing, right? But there's a way we always manage that, right? Don't worry. As we go deeper, it's going to make sense. So we have faculty and we have department. The faculty now has a relationship with the department, right? So meaning a faculty, right, can have many departments. Are we good?
Yes, sir.
Great. So how do we represent that now? How are we going to represent that? It's just simply let's duplicate this. Duplicate this. So this is faculty to department, right? So it's now going to be one faculty, right? So it means I'm going to use one here. One, 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 one. So more like this, this, this. Do you get it now? A faculty can have many departments, and many departments can belong to one faculty. Do we all get it?
Yes, sir.
That's clear, right?
Yes, sir, we get it. Yes,
Yes,
sir.
that's clear.
Great. Now, there is a relationship between this department and the course. There's a relationship between the department and the course, right? Like every department have the course they offer now, right? Like I did petroleum, so for the department, there are some petroleum courses that was offered by that department, right?
Yes.
But it's not going to work because in university system now, when in year one, right? In year one, there's what we call general course, where you take Math 101 and Math 102 and or which everyone takes. So things like that, it's somehow tricky trying to create a relationship between them. But you can actually create a relationship between this student and this department. You get a
Yes.
student can belong to one department. That's a one-to-one, right?
Exactly.
You get it? Yeah. So how do we represent that? It's simply since it's one-to-one, then a department can have many students, right?
Yes.
Right?
Yes.
Great. So that should tell the kind of cardinality or symbol you're going to use. So since I want to make this horizontal, I just need to come here, then make it straight. Then that's all. Take it here. And I'll get this right. Anyhow, you want to do it. Okay. So we have students a department can have many students, and many students can belong to one department. We all get it now, right? So that is just a very simple and basic ERD structure. We can have more. I would have shown you a picture of where you are asked to build a school management system. I wouldn't expect to see just four entities here. I would expect to see over 10 or 15 or 20, depending on how you interpret it or how you want to design it, or maybe the client gave you a specification on how they want the software to look like. So it's based on what the client wants. You go ahead to design something that suits the client, right? Are we good?
Yes, sir. We are good, sir.
All right. Don't worry, we'll soon end. So finally, from ERD to code, how do they tally now, right? How does it work, right? So the ERD provides a direct roadmap for building your C# class. Like I said, every entity you have is actually a class in C#, okay? So student entity is actually a student class. Course entity is actually a course class, right? In our next class, which is on Thursday, we'll go into the code and see how to create classes, how to create student class, course class, and how to declare or give properties to these classes, right? We get it now, right? Then for the attributes or properties, how we write that in C# is public int, student ID, get set, property, and all these would understand in our next class. Then one to many, how do we represent that in code? Everything will make sense. Okay? So that's the end. Any question? Any question?
One question. So this last relationship you did now, you did not like put the foreign key anywhere. So I
Which one?
was wondering
Which one? Let me go
the
to the
department and student.
okay, wait, wait. All right. So department, okay. Department has a list of students, right? Has a list of students. So in C#, right, since it has students, we make use of their different data structure to represent a list of students, right? So there's what we call one of the data structure is what we call um list. That's why I didn't want to go deep into this. Student. list of students. This is how we represent our one-to-many. Yeah, this one-to-many list of students, which is referencing this student. Don't worry, in the next class, right, when we go into the code proper, it's going to make sense, okay? I didn't want to really touch this now until when we go into the code. It would make sense.
All right.
Right?
Okay.
Yeah. Okay, so if there is no question, thank you, and do have a wonderful day, night, or whatever. Bye
Sorry,
bye.
sir, I have a
Okay,
question.
go
Sorry.
ahead. Yeah.
Okay, please, can you recommend, I don't know, any book or any
Yeah, I dropped
material
one,
that we could.
knackoff. Yeah, knackoff. If you have not seen the knackoff textbook, I dropped one there at the very
Basic
beginning.
of the beginning of this class, or
Yeah, don't worry. I'm going to reference. I'm going to drop link it up today so that you just see it and download. Yeah.
all right, thank you.
Do
Because I
that.
joined the class. Thank you.
Okay, I'll do that. Yeah. All right. So if there's no question, see you guys on